Now I'd like to look at the hydrogenation of alkynes. We've got excess hydrogen here, and what I want you to see is that we start off with an alkyne and we end up getting an alkane as a product. So the hydrogen is going to add twice, once to form a cis-alkene and then once to form an alkane. I'll show you how this looks by the arrows. So we've got our structure here, which has got 4 C's in a row. We've got a C here and a C here. So we've got our palladium and we've got our hydrogen, and what we can see is that the hydrogen will break apart and the electrons from the HH bond will be used to form a new PD hydrogen bond. Now to this situation where we've got these two hydrogens here, we can now add the alkyne, and the arrows are going to go in a cyclic fashion that will have this C bonding to this H, this bond breaking, the electrons going to the palladium, and then this bond breaking and forming a new bond with this C here. The net effect is that we end up with a cis-alkene. The reason I know this is cis is because the hydrogen's added to the same side of the double bond. And this will be important later when we want to make these things. We can find a way to do that using a similar system. Now we've still got the palladium, we've still got the hydrogen. And again we can have our palladium, our two hydrogen atoms, and to this we can add our cis-alkene. Same story with the arrows. As you can see, it doesn't matter what direction you put the arrows in, whether you put them in clockwise or counterclockwise, just as long as you're showing what's going on with the formation and breaking of those bonds. So the final product is an alkane. There were no hydrogens on these carbons, now we have two hydrogens on each of them.